So we're going to continue on with our discussion about volume, and also we're going to look at three-dimensional shapes and how to identify them. So let's look at this to start with. We're going to talk about standard cubic units. Now, one of the things you may remember is when we did the trying to figure out how many Unifix cubes would fit into the room, we used cubes. The reason why we use cubes is we can actually see how many fit. The thing is that if you have a unit of length, you're going to use a ruler or something like that, and that's just how long something is. But if you're trying to figure out how much space like a desk has, you're going to need to use something that you can make squares out of, because just giving me the unit of length is not going to be helpful. It would have to be one length by another length. It'd have to be like, let's say that your desk is 2 feet by 3 feet. And that's fine, but you're still using two measures. You could say that your desk is 3 feet high or 4 feet high if you wanted to, but that's only one unit. So let's think about this in terms of if we were trying to figure out like how many Post-it notes would fit on a desk, we'd need to know how many squares would fit on, and that's why we use what are called square units. So the way those are referred to is centimeters squared or square centimeters, if we're using centimeters as our units. So that's the first part here. Now moving on here, what we have is we have also the problem of how do you figure out how much three-dimensional space something takes up. Yeah, we could figure out how many Post-it notes would fit in the classroom just by putting Post-it notes on the floor, but that doesn't give us an idea of the element of height as well. So that's why we use what are called cubic units, because then it allows us to measure length, width, and height. And remember, for the volume, it's going to be length times width times height is going to be the most usual formula that we're going to use to figure out the volume of something. But again, that's when we use it, it's going to be centimeters. If it's centimeters cubed, that's the way of indicating centimeters cubed, or cubic centimeters. So those are the units, and here is an example. Cubic centimeter, if it has a length of an edge of 1 centimeter, then the area of the face, the area of one of these sides is going to be, or faces, is going to be 1 times 1, which is just going to be 1 again, but now it's going to be now it's actually going to be in centimeters squared. And if we're going to measure how much space the whole thing takes up, in terms of three-dimensional space, we'd be using centimeters cubed. And it's the same way for cubic inches and for cubic feet. If you think about it, a cubic centimeter is about the size of a bean. So you can visualize that, the size of a bean. A cubic inch is about the size of a marshmallow. And a cubic foot is about the size of a boxed basketball. It's just 1 foot by 1 foot by 1 foot. Now, in terms of meters, we can do that as well. If you remember in class, we used meter sticks to kind of create a box, and it was 1 meter by 1 meter by 1 meter. So that's 1 cubic meter. So that's pretty big, and it surprised me kind of how big that was when you looked at it, because I could fit inside that box, and anyone could too. But this idea of cubic meters, that's an important thing, because that's how we measure a lot of times the three-dimensional space in an area. Now, in terms of here, these problems here, which unit of measure would you use to find the volume of a bathtub? Well, you're probably not going to use centimeters. If we go back here for a second here, you're probably not going to use centimeters, because that would be a lot of beans. You're probably not going to use marshmallows, because that would be a lot of marshmallows. You might use cubic feet. That would be my guess on that, because that cubic meter looks pretty darn big, so I would guess feet cubed would be the best measure for a bathtub. In terms of your kitchen size, you could fit several of these into your kitchen. So therefore you would use meters cubed. And for a brick, that would be a little bit different. You wouldn't want to use a foot a foot by a foot by a foot, unless it's a really big book, a really big brick. So you'd probably use centimeters cubed or inches cubed. Probably inches cubed would be the best unit. So in terms of geometric solids, the ones we've been working with, and I identified before, some of them are listed here. Figures have 3 dimensions: length, width, and height. So in this case here, this is a rectangular prism. This is a cylinder. This is a sphere. This is a cone, if you notice. For a rectangular prism, all the sides are rectangles. There might be a square in there as well, but all the sides are also rectangles. For a cylinder, we've got 2 circles on the top and on the bottom. They're connected by another piece, but those 2 circles are parallel to each other, which means that they would never ever meet. And you think about it as like an orange juice can or something like that. If you look here also, for a rectangular prism, it has 3 sets of parallel sides. We've got the set on the top, this set on the bottom, then we've got the set on the right, and the set on the left. And then we've got another one that I can't really draw in as well. But we've got 3 sets of parallel sides, and they make a box, things that you're used to in terms of a box. Spheres, they just have, if you look, sphere is a special case because it just has length and height and width, but it's just a circle all around. A cone has a circle on the bottom, and then it goes to meet up with a point, and that most likely thing is that you probably recognize as an ice cream cone for that. So those are some of the shapes that we'll be working with. In terms of some vocabulary, and this is going to be important, we're going to use these terms: faces, edges, and vertices. I'm going to go over exactly what they mean. A face is a 2D figure that makes up a flat surface of a 3D solid. So the example of the face that they have is right here. This is a face. It's basically, in this case here, a rectangle. So that's important to recognize. So now, an edge is where 2 faces meet. So here, that's an edge. 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 And then that's an edge. And there's some other edges that I can't draw because you can't see them. So those are all edges. And finally, the vertexes or vertices are where they're pointy, where 2 edges meet. So if you look, a rectangular prism will always have 6 faces, will always have 12 edges, and will always have 8 vertices. So let's look at this problem down here for a second. How many faces does a triangular pyramid have? Well, if we count them up, there's the bottom piece, then so that's 1, and then we got the 3 triangular pieces that meet up at the top point here. And so that's going to be a total of 4. And how many edges does it have? Well, if we count them all up, it's going to be 1, 2, 3, 4, 5, 6. So it's going to have 6 edges, 4 faces. How many vertices does it have? Well, let's look again. I can count them up. So we got 1, 2, 3, and 4. So it's got 4 vertices too. So a lot of this identifying things is just counting. All the geometric solids are called prisms. All these geometric solids are called prisms. They have bases that are parallel to each other, and they match. So that's a triangular prism because the top and the bottom are triangles. So you can see triangular prism. We always name prisms based on the bases. So this one here, this is going to be a rectangular prism. Because if you look, it's rectangles all around. And this last one here is going to be a hexagonal prism. Again, if you notice, one of the things that's really key to understanding about a prism is most of the sides on a prism are going to be rectangles. And that's an important difference between that and also pyramids. Because pyramids, the base of a pyramid is how we name it. Like, for example, this one here is a triangular pyramid. This one here is a square pyramid. This is a hexagonal pyramid. But the thing that's important to recognize is that they all come together in one vertex at the top. And they're mainly triangles. So the face on the sides of the pyramid are all going to be triangles. So I'll just name these quickly again. So probably the easiest way to figure out if something is a pyramid or a prism is look at the sides, see if they're mainly triangles or mainly rectangles. If they're mainly triangles, it's likely that it is a pyramid. If it's mainly rectangles, then it's likely that it's a prism. And then look and see if it comes up into one big point, like here. Then also look and see if there are two, or at least two parallel sides. That's it.